Let's do one more problem before we take a look at ALEKS and see what these problems look like on ALEKS. The last question on this worksheet is asking you to figure out how much stuff you would need to add to 300 milliliters of a solution to make a buffer with a specific pH. This is a really useful skill. If you're ever working in the lab, this is the type of thing that you would actually need to calculate. It's not unusual for somebody to say, whip up 300 milliliters of a buffer with a pH of 10.61, and you need to actually, there's no shortcuts. You need to actually calculate it out, just like we're about to do. So to do this, we are going to use Henderson-Hasselbalch, pH equals pKa plus the log of the concentration of the base over the acid. And in this Henderson-Hasselbalch equation, we know the pH that we're trying to get. It is 10.61. And we don't right now know the pKa, but we can figure it out because the problem gave us a Kb and we can totally figure out the pKa. And also we know the concentration of the CH3NH2, which is either going to be the base or the acid. And that maybe is the first thing we should figure out right now. So this CH3NH2, is that our base or is that our acid? Well, remember, we're going to compare the formula to CH3NH3. Whichever one has the most hydrogen atoms is the acid. CH3NH3 has 6 hydrogens. CH3NH2, that has 5 hydrogens. So that means this is our base. So now that we know that, we know the concentration of our base. These are the 3 things in this equation that we need to know. And what we are trying to solve for is the concentration of the acid. So that's what we're going to start with. That's what we'll do first. The pH is 10.61. That's our desired pH. pKa, let's do that next. I'm going to do that down here at the bottom. So remember, pKa plus pKb equals 14, just like pH and pOH are 14. The Kb, which is what's given to us in the problem, can be used to calculate pKb. pKb is negative log of Kb, not Ka, Kb. pKb is the negative log of 4.4 times 10 to the minus 4. 4.4 times 10 to the minus 4. Take the log of that. Our pKb is 3.36. So our pKa is 14 minus the pKb, which is 14 minus 3.36, 10.64. 10.64 plus the log of our base concentration, which is 1.10, divided by our unknown. Now, unfortunately, our unknown, the thing that we're trying to solve for, is in a real bad spot. It's on the bottom of a fraction that we're taking the log of. So we're going to have to do a lot of math to get down to that acid and solve for it, but we can do it. So I'm going to start just with the simple part of solving this problem. Negative 0.03 is equal to the log of 1.10 over the concentration of the acid. And I did that just by moving the 10.64 to the other side. And then what I have to do is get rid of the log. So I have to do the anti-log, which is raising both sides, 10 to the both sides. I'm definitely not a mathematician. I do not know the right way to phrase that. 10 to the negative 0.03 is equal to 1.10 divided by the concentration of the acid. So that's the mathematical function that gets rid of that log term. And now we're just going to rearrange 10 to the negative 0.03 times the concentration of our acid is equal to 1.10. And now we can solve for the concentration of the acid. And it looks like we need our acid concentration to be 1.17 molar. That's the concentration that we'll need to get the desired pH. So we've got that part figured out. Is that what the question is asking us though? Let's look back up. It says, how many grams do we need to add to 300 milliliters? So now the problem is telling us we want to make a 300 milliliter solution that has this molarity. How are we going to go about doing that? So we're going to say 1.17 moles of our acid, which is CH3NH3Br per liter. We actually only want 0.3 liters, 300 milliliters. So that tells us that we want to add 0.354 moles CH3NH3Br. And how many grams is that? 1 mole is, let's add up that molecular weight, 12 plus 3 plus 14 plus another 3 plus 80 for the bromine. That's a molecular weight of, I think, 112. And that gives us an answer of 39.6 grams. That is how many grams we need to add. So again, another really long problem. All of these buffer calculations, they take a long time. There's a lot of steps in them. Make sure you take really good notes about what to do in what order. Let's now take a look at what kind of problems are on ALEKS.